Okay, here's the second example. All right, so we're going to start the same way where you're going to find the maximum R values. This time we have sine 2 pi, and that still has to be between 1 and negative 1. Okay, so when we substitute absolute value of R, and then we use 3 times negative 1, 3 times negative 1, because I'm substituting negative 1 in for sine 2 pi. So I get the absolute value of 3. And then I guess I was substituting positive 1. When then I do the absolute value of R equals 3 times negative 1, I get the absolute value of negative 3. So I have sometimes it's 3 and sometimes it's negative 3. So that means it'll go, they'll have some that go all the way to 3 on one side and some back up to get to 3. So let's find out where those are. So put in 3 first for the positive one and put it into the equation, and you get sine 2 theta equals 1. All right, now we want to know what 2 theta could be. So where does theta equal 1? It equals 1 at pi over 2. Where does sine equal 1? Sine 2 theta. It equals 1 at pi over 2. But we have to keep going because this is a 2 pi. And so you have to go all the way to, it's double. Your normal domain would be to 2 pi. Your range would be to 2 pi. But now because it's 2 theta, you have to multiply that too. So you have to go to 4 theta in order to be able to divide by 2 and get all the points that you need. So adding pi over 2 plus 2 pi, you get 5 pi over 2. So 2 theta are those two. Make sure you understand that when you have an angle that's different. So then you divide theta by 2 and you get pi over 4 and 5 pi over 4. So there you go. That's within negative 2 pi to 2 pi when we get actual theta. So we know that we have two different things it could be. It could be 3, and 3 it's going to be pi over 4 and 5 pi over 4. And negative 3, it's going to be 3 pi over 4 and 7 pi over 4. And we write that, this is how you write this. You say absolute value of R equals 3. That gives you your plus or minus 3 at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay? So that is finding our maximum R value. So when you go to make a sign chart, you know that at pi over 4, so I'm going to go ahead and write all my, well, I'll just wait. Sorry. I'm going to find my zeros next. I'm getting ahead of myself. So finding the zeros. Set the equation equal to 0. This is the easiest thing. Sine 2 theta equals 0. Well, where does sine equal 0? It equals 0 at 0 and pi. Now it's 2 theta, so I have to go all the way to 4 theta. So if I keep going, it would also be 0 at 2 pi and at 3 pi. So then dividing by 2, it's 0, pi over 2, pi, and 3 pi over 2. Each one of these are divided by 2. Okay, I'm over here now. So I know I have 4 zeros going around. I'm looking at symmetry. Symmetry. So first, I got to figure out what is the symmetric to. It's a sine, so the first thing I'm going to try is pi over 2, because sines are more than likely symmetric to pi over 2. So I know that if I put in negative R, negative theta, I get negative R equals 3 times sine. And because they're both negatives, and then you pull out the negative, you get negative R is negative 3 sine theta, and dividing by negative 1, you get R is 3 sine theta. So I found out immediately that it was symmetric to pi over 2. Theta equals pi over 2. Is it symmetric to the pole? Yes, I did all the work. You can see here. It wasn't when I put in R negative theta. It was when I used the r and negative r and pi minus theta that I got a yes. So it is symmetric to both the polar axis and the theta equals pi over 2. So I have symmetry both ways. Now you can see I'm doing this blue on the graph. There's a symmetry, which means I only have to graph one quadrant, because I can flip this one this way across the polar axis, and I can flip it this way across the theta equals pi over 2. So I only have to graph a few points to get this one to work. And I know points already. I know from finding the zeros, so I'm going to like use orange or something so you can really see it. Okay, I know from here, finding the zeros, that it's 0 at 0. So I know I have 0, 0 without plotting it. Pi over 12, I'm going to have to use my calculator, and I get 1.5. So here's pi over 12, and I'm going to plot 1.5. And here's what I mean. It also means, because it's symmetric to the polar axis, I can put a point there. And because these two are symmetric to the theta equals pi over 2, I can put a point over here. So I'm going to put a point here, and this one I could put a point there. Okay, so you have those 4 points just from one point. So let me do this orange point. Okay. Now, that was that point. I'm moving up on now that was this one. Now I'm on pi over 6. I substitute pi over 6 in, and I get about 2.6. So here's my pi over 6 for this point. See on the graph where I'm starting to do orange. There would be one over here at pi over 6 down on the bottom in quadrant 4. There would be one in quadrant 2 that matched it across theta equals pi over 2. And there would be one now on the third quadrant. So I've got 4 points out of that. Okay, pi over 4, you get 3. So, look, here's where that was. At pi over 4, I'm up here and looking at my biggest. So this is as big as it's going to get. So at pi over 4, I got 3. So we have one in quadrant 1, one in quadrant 2 matching in quadrant 3, matching in quadrant 4. All right, at pi over 3, I got 2.6 again. So there we are. Quadrant 1, you can see these dots coming. Quadrant 2 across the other axis. Quadrant 3 and quadrant 4. And the last point we graphed was 5 pi over 12, which is right here on the graph. And that was 1.5. So this point here, across the theta equals pi over 3, across the polar axis would be here and here. All right, and remember that there was another 0 at pi over 2. So the other 0 would come in here at pi over 2. So we only needed to do that one quadrant, and we got all those points, and it makes a rose. This is called a rose. 4-petal rose. Okay? So that was example 2.